Hi everyone, welcome to the latest soldering tutorial. As always, thanks for tuning in. Now in this one, I'm going to show you 3 different ways to remove your electrolytic capacitors. Different sizes here. I'm going to start with a smaller one on another board. So the first method I'm going to show you is the 2 soldering iron method. Quite a common method. Iron on each end, wait for the solder to melt, lift the device off. Basically the same method as soldering tweezers, but I prefer the 2 soldering irons, just find them a bit more flexible. Then I'm going to do the hot air method, which I'm not a massive fan of, but I do use it at times. I don't like putting too much heat into these devices. And when you get the large electrolytics, like this one here, I find them first 2 methods don't really work very well. You're going to put a lot of heat into this to get this off. Heat's got to travel a long way underneath to melt all the solder. Now the third method I'm going to show is quite a controversial one. A lot of people are not a fan of this. It's the twist method. Basically just twist the body very slightly each way and eventually the pins break underneath the device. Just lift the body off, take the remnants of the device off the pads, clean it up and you're good to go. Now if this method's done correctly, it's really safe. I've never had a problem with it. I know a few people don't like it, and that's the method we're going to finish with. Like I say, we're going to start with the 2 soldering irons on a small device, and yeah, we'll get straight into that one now. Right, so come on to the first of the 3 methods I'm going to show you in this video. This is the one where I use 2 soldering irons. Basically I'm going to remove this C16 up here. So basically what we do first, I'm going to add some rework flux to both joints, and then we're just going to tin both irons, small amount of solder, go into the joints, just wait a few seconds and it should flow underneath, and the components should be quite easy to remove. So first thing we do, like I say, is add the flux. This is just going to aid the solder running underneath slightly quicker. So just get some flux added around them joints. Get both irons tinned up, a small amount of solder. This is probably my favourite method for small electrolytics. It's a similar to method to the soldering tweezers. Just find 2 irons is a bit more sort of flexible. You come from different angles. So you'll always see me using 2 irons over soldering tweezers. What we do then, this is why I like 2 irons. You can come in from different angles if you have to. Getting on both joints, just wait a few seconds. Component moves off. Really easy. And that's how easy 2 irons are. So I'd use this method for the smaller electrolytics, probably the next size up, the 2 smallest sizes. When I get to the middle sizes, probably a hot air gun, which is a method I'm going to show next, and later on I'll show you the twist method. So I'll move on to the hot air method now. Right, so moving on now from the 2 soldering irons method, come to the hot air method. Now this one's a step up in size. It's about 7mm from one side to the other, whereas the last device was 4mm. This should still be alright for 2 soldering irons, but you can, like I say, use hot air, which I'm going to show now. Now hot air can go seriously wrong, so I'm going to show you after this one the dangers of using hot air and pumping too much hot air into these devices. So anyway, we'll get straight on with this one. I've pre-fluxed the joints. I've got my station set to about 400 degrees Celsius and my air about 90. I'll use a quick H61DA station. So anyway, let's get straight on with it. You will hear the air noise on the way through, that's just unavoidable. So yeah, let's see how it goes. So one thing with these, just never try and take them off too early until the solder's fully melted. The pads underneath and the traces underneath these are quite slim normally. So just got to be patient. So just circle between the 2 joints. Also hot air will melt your plastic base, that's just unavoidable. Just got to be patient. I like to just try it a few times to see what's happening. So I never force it off. You can already feel it getting slightly looser. It's got to be nice and patient. In a second now it should come off. And that's it. Just safely off. You've got no damage to either pad. Like I say, there is too much. If you get too much heat into these devices, it can be pretty dangerous. So I'm going to show you an example of that after this one. This one's actually not too bad because you haven't got a large plane attached to the negative end. But as you can see, it still took quite a long time to get this off, whereas 2 soldering irons would have done it a lot quicker. So yeah, we're going to move on now from this one. Like I say, I'm just going to show you the dangers of the hot air method, and that's what I'm going to show now. Right, so moving on from the 2 soldering irons method, I'm going to show now the hot air method. Now I'm going to remove C36 down here. That's about an 8mm width from over this point here over to this point. So a step up in size from the last device we've just shown. Now it's actually a lead-free board, so it's going to take a lot of heat to get this off. So I've got my temperature set to about 420 degrees Celsius and the air's on about 100 on my hot air station. I use a quick 861 DA station. So yeah, this will take quite a lot of patience, quite a lot of heat. And trouble with hot air, it will melt your plastic base. But when you get, this has actually got a plane sort of joined around this end, so it's going to take quite a bit of heat to get that off. So please bear with me, this will take a short while. But yeah, let's see how it goes. So like I say, we'll hear some air noise going through the process of removing, so please bear with me. And yeah, let's try and remove it. Normally I'd bring the sort of station, the nozzle from sort of this direction round to here, just keep going in this direction, but with this one I'm going to do it slightly different just so I don't block your view, and try and do it from above. So yeah, this is how it goes. So you've got to be really patient with these. One thing, never try and put it off too early. You've got a danger of taking the pads off. But you will see the plastic melting around the base. But we're really patient. Just keep trying as you go through. As you can see, the plastic's melting quite badly. This is why the next method I'm going to show you, the twist method, is a really good method for getting this sort of type off. You can already see the body swelling up, which isn't a good sign. There you go, starting to come loose. There. Right, so hopefully you've just heard that pop. That's the trouble with putting too much heat into these devices. The tops can swell up and pop, and it can be quite dangerous. I've actually seen them split open. You can actually see the curve on this. This is the one that just went pop coming out. This is a brand new device, should be dead straight. I'll just swivel that around slightly so you can see the, should have a dead straight top. This one's actually swollen up, device has popped, and it can be more dangerous than that one. So yeah, if you're going to take these off of hot air, please be careful. So anyway, that's why I'm going to show you the twist method now, and that's why in certain situations I prefer that method over this one. So yeah, we'll move on to that one now. So coming on now to the last method, following on from the hot air method, coming on to the twist method now. A lot of people find this a bit controversial, a lot of people don't like the look of it. But yeah, when we get to the large components, I'm going to show one after this. I think this actually, it's really helped me out in the past. You can do it on components like this where you got quite thin traces coming out. But this is a sort of component, this is quite a small component. This is one I would do with 2 irons, but I'm just going to show you. you can actually do this with the twist method as well, and I've never really had a problem with this. It's a lifesaver in some situations. I'm going to show one of them after this one. So I'll just quickly show you how I do it. I've seen other people sort of do it and they pull the component up a bit quick, but just be patient basically. Twist it slightly each way. I've got a nice pair of height cutters that I just grip it with. Just twist it slightly each way, just a small amount. You'll sort of know when it's broken, when the pins are broken from the main body, and then just tweak it up, and I can feel it now. It's already gone. That's one gone, and basically that's just going to come up. Just don't pull it up too early. Twist gets bigger and bigger. There you go. I'm just going to move the base, the plastic base. Underneath you've got two pins still attached to the pad, so I'm just going to get rid of them, clean it up, and we'll see what the result is. Yeah, a lot of people find this quite controversial, this method, but if it's done right, it's a really good option, especially for the really large electrolytics. So let's just get rid of these remaining parts of the component, just take them off. Let's do the other one. It looks quite a scary method, but if you've got some old boards, just practice away, and you'll see the great results you will get. Just clean that one up. That one, just give it a quick wipe cleaning fluid, and you've got a perfect result. It's got no damage there at all. The key is just be patient, don't put it up too early. So I've never really suffered with a problem doing this method. Like I say, it's really helped me out when I get to the large ones that are on ground planes. So as you can see, got two perfect pads, no damage at all. It looks quite a scary method, but it's actually really good. So what I'll do now, I'll move on to a large one on a ground plane, and we'll show you the benefits of this twist method on that one. Right, so the final component I'm going to show you in this series of videos is this rather large C4 electrolytic down the front here. Now this is probably 4 times the size of the one I've just removed with the twist method. Now as you can see down the front, this pin's attached to a very large plane running right round here, right round the other side. When I take the device off, you'll also see this pad's attached to quite a large plane as well. So that's the difficulty with this one. If you've done the hot air method, as you saw from the hot air method in the previous clips, the electrolytic took me about 2 minutes to remove the component, and it actually went pop near the end. Now this one is a lot bigger than that, so this is probably, you're talking 3 minutes probably. Some people might put a hot plate underneath and give the board a general warm up, but yeah, that could work, but I still wouldn't do that. I'll just twist this off in a matter of probably 30 seconds, probably less. So yeah, let's see how it goes. So like I say, don't dismiss this method. If you've got any scrap boards, try it on it. You might be pleasantly surprised. So let's see how this goes. Again, I've just got me height cutters I use. So with 2 soldering irons, this one will be nigh impossible because the heat needed to travel underneath. The hot air, you'd be on it for so long, just wouldn't be possible really to do this without the body swelling up. I can already feel that going. Because of the large planes, they're actually going to protect this. And that's really simple. Broke the body off, no problem. Right, so now the body's twisted off, I'm basically going to struggle now to lift this plastic base over these pins. So all I'm going to do, pushing down on the plastic base to protect the pins below, I'm just going to clip that top part of the pin off. So just with your cutters, just push down on them. That way you've got no way of the pad and pin below lifting up. So just clip them off. Same with that one. All you've got to do now, just lift the plastic base off. And there's the underneath. So no damage at all. Perfectly clear. So what we're going to do, we're going to get them removed, clean the pads up, and here we'll have a look at the result. Right, so just before we remove the pins, I just want to talk about the planes underneath. As you can see, this pad was attached to this large plane going all the way around here, and this one's obviously attached to this plane going way around here. So with 2 soldering irons you would never have got the heat underneath right at the length of that pad to get this device off. Same with the hot air gun. This is a much bigger device than the one we struggled with earlier. So the twisting method for this type of device on these sort of planes, to me, I know people will dismiss it, but to me it's definitely the best option. So we're going to get these, well, the remnants of the device off and clean it up, and yeah, we'll see the results. So I'm just going to add some flux just to both pads, which is just going to aid with the solder melting. I've got a larger soldering iron tip now because it's going to take quite a bit of heat to get these off. This one's actually a lead free board, so I've got my iron set to about 370 degrees. So I'm going to remove the remnants of these. So that's that one taken off. Let's get the other one done. Wait for the solder to flow all round. Drag that out of the way. Alright, let's get some solder braid on there. I've already added some flux to my braid, as I always do. Let's just clean these up. So every method's got a time and place. This is just for this type of device on these type of planes. To me, this is definitely the best method. So yeah, don't dismiss this method. Please give it a go. Just, if you've got any scrap boards, definitely a bit of practice first. The key is just be patient when you're twisting it. Don't be too keen. So I've had really good results over the years with this, especially on the one I'm doing now. There's times when I've really struggled in the past with sort of the hot air method, 2 soldering irons, but since I've done this method, I found it really easy. Right, let's just give it a quick clean with some cleaning fluid and see what we got. Obviously a bit of burnt flux all around the area. Let's just get all that off. So I use all the cleaning fluid and cloths I use, I've sort of spoke about in other videos. And that's the finished area pretty much. Still a little bit of flux on there, but overall got a great result. As you can see, got no damage at all. Now that was really quick to get off. So yeah, please try this method in the future, you may like it. There is one other method some people do. They basically cut the body of the device off, but I'm not showing that method because it's one I've never personally used, and yeah, I don't really fancy that. But I've always said, if you've got a method that works for you, that's the one to use. Anyway, I hope you've enjoyed these sort of methods that I've used. Yeah, if you've enjoyed the videos, please like and subscribe, and I'll put a few more photos up now, and I'll see you again in the near future with yeah, some more soldering videos. So again, thanks for your time, and I'll see you soon.